We live in a world that is dynamic and in color. But why is vision testing still in black and white and static? To answer these questions, we must first understand two concepts: the biology of the human eye and the mechanics of vision testing. Acuity is the measure of how clearly we can see. Measuring visual clarity is a function of the size of the image and the viewing distance. The original visual acuity test was being able to identify the stars in the Big Dipper. The acuity endpoint is the smallest arc width image identifiable at a specific distance. Good acuity let early hunter-gatherers distinguish predators from game to enable them to eat rather than be eaten. To understand how we see, we need to realize that the eye is a biological machine. The eye is a sphere with four primary parts which determine the quality of our vision: the cornea, lens, retina, and fovea. The cornea is a dome-shaped cover at the front of the eye that protects the pupil and iris and bends light to help the eye focus. The pupil is the black opening at the center of the cornea that allows light to enter the eye. The iris is the colored circular area that surrounds the pupil and adjusts its size to control the amount of light entering through the pupil. Acuity is the measure of visual clarity. As light passes through the biological lens, the lens changes its shape to have that image focused on the fovea. The proper focus of that image is what lets you see clearly. Inside the retina and surrounding the fovea are rod-shaped photoreceptors which are sensitive only to the intensity of light, which helps our night vision. Accommodation is the process of the lens automatically changing its shape to enable that image to be focused on the back of the eye. When looking at distant images, the shape of the lens is flattened. When looking at near images, the shape of the lens becomes rounded. Changes in the alignment of the lens also affects acuity. Refraction is the process of a doctor using spherical, cylinder, and axis lenses to measure and compensate for optical errors in a patient's eye. Refraction compensates for the misaligned orientation of the lens. Cylinder compensates for the forward or backward tilt of the lens. Axis compensates for the horizontal misalignment of the lens.